one of them in the US, the Amanti.
Are you guys interested?
But we have epithelial maps on every single patient, ever since OCT.
Yeah.
He was using that. He was using that in the past.
Here's a comparison, direct comparison, OCT to ultrasound, which we published in the JRS. And what we showed was that centrally the measurement was quite similar. But as you went out even to the 3 millimeter zone, the differences could be up to 3 microns, and beyond that, worse. Of course, OCT at this time is only going out to 6 millimeters. But essentially, the accuracy of OCT is lower, which is fine. It's a much more convenient test. You can do it on everything. When you want to have the backup of the accurate test of what you do, because it costs you X dollars to get a patient through the door, and you want to be able to treat them and give them what they wanted, and not send them away without treatment when you couldn't. So for us, the Artemis patches is like the safety net, and only ends up rejecting 15% of the 9% of cases that are equivalent. 84% of our patients are salvaged by an ultrasound. So that's just another example. Oh, yeah, and of course the classifier, which eventually we'll get into OCTs, but currently, let's see, we did the work on ultrasound, is there. Okay, so about 70% of our interstromal work we can do with an OCT alone. 30% in our clinic is still having to go to ultrasound. And you can see here, on, for example, on the flap thickness measurement, if I move the cursor 1 pixel, that's 9 microns difference. 1 pixel. Another pixel. Another pixel. Another pixel. In other words, the resolution isn't that high. So you have to be aware that an OCT is a quick and dirty measurement that'll help you in most cases get the answer. But you still want to have a backup if you really want to get down to the diagnostics. Here's an example of a very, very, very thin flap here over a smile. And you're not going to see that at 1 year. You're just not going to see it. But on ultrasound, you can pick it up. Look, right there. Absolutely crystal clear. There it is. Okay? 10 years later. Okay, so posterior chamber. Right. So why does Starr say, well, you know, the meta-analysis which was published by a paid consultant in that paper reviewing whether UBM helps ICL sizing, well, he came to the conclusion it was kind of the same as white to white. It's like, yeah, he did. That's right. That's the correct conclusion. But the wrong message. The conclusion was correct. If you take commercially available handheld middle frequency scanners and you look at their sulcus repeatability, it's about 0.5 millimeter. Well, the ICL comes in 0.5 millimeter sizes. So if the repeatability of the measurement is about 0.5 millimeter, yeah, I'd agree with you. It's kind of like a flipping a coin, whether the UBM is going to help you with your ICL sizing. But with the Artemis 1, it was 0.2 millimeters, and with the Insight, we found it to be 120 microns. Lateral accuracy, repeatability. Now this makes a big difference because, and we were studying this, so we did this with Carlo Lovisolo, who was like Mr. Okay, sorry, this is the wrong slide here. Pre-op OCT, white to white. We don't know what the sulcus is. Some people measure the pigment epithelium distance. It's a proxy for the sulcus. But that might be one thing, but you still don't know what the zonular plane is. And you still, therefore, cannot calculate the lens rise and therefore what the ICL separation would be in that eye. And you won't be able to calculate the angle reduction that you'll get in that eye. What you can do once you have high frequency ultrasound. So post-op, you can, of course, measure the gold beautifully, nice and quickly. I do it immediately post-op. I do it the next morning, and I watch it go down as the visco disappears. No problem. But with an ultrasound measurement, you can get exactly the position of the foot plates. And sometimes these oversized lenses are not. It's just that the foot plate is twisted. And all you have to do is do that, and that's it. People talk about rotating the lids 90 degrees and that fixes it. What they're actually doing is untwisting the foot plate. It's not that the vertical is that much different from the horizontal. It's a little bit different. It's that they're unclinking the foot plate. So being able to diagnose whether it's an oversized lens or a lens that needs jiggling is really helpful, because removing the lens removes everything at the endothelial cells. So it's not a great operation for the patient in the end. The true volt of the lens is the volt of the lens, but the lens separation depends on the lens rise from the zonular plane. And if you don't have an image on the zonular plane, you don't know what the lens rise is going to be from that negative. But what is, you can't do it at the highest standard unless you've got the image. It's as simple as that. And you can't get behind the iris with light. You can only do it with ultrasound. So here's an example of a patient that was maybe oversized, but it wasn't. You see, the haptic was twisted on one side. And this patient only needed adjustment. Same lens. That took 2 seconds to do. Hyperopic ICL, checking the position. I mean, this lens is critical that your PI stay open. Everything is quite black. Hyperopic ICLs are tricky. It's not available in the US, but it's a trickier area because their anterior chambers are usually less deep. So it turns out that from external measurements, the best you can do in terms of an error of 0.5 millimeter, from white to white it would be 38% of the eyes. If you're measuring the angle, it would be 32% of the eyes. And with anterior chamber depth and angle diameter, you get to 26% of the eyes, having a predicted error of more than 0.5 millimeters in sizing. Whereas with 0.12 measurement accuracy, the chances that you'll have an error of 0.5 millimeters is less than 1%. So when you consider how forgiving the ICL is in terms of, these terrible predictability of the error, and yet we only have to exchange maybe 1 or 2% of the lenses. It's very forgiving. Imagine what your exchange rate goes to if you have a measurement this accurate in size. And we think it's, well, I'm not going to call it 0, but let's say that it goes from 1 in 40 to 1 in 400. That's a conservative measurement. And it means, to me it means that something like the ICL could actually become the primary vision correction procedure in the world. Because to do refractive surgery on the cornea, you need $1 million and a year's training. To do an ICL, you got to finish your residency. That's it. Well, and maybe have a high-frequency ultrasound scanner, which you can lease. And then you're a refractive surgeon with no barrier to entry. So I believe that the market could actually shift away from corneal refractive surgery simply by market forces, not because it's safer, because it's safer to stay outside of the eye. But that's not what determines what patients get, right? Patients get what surgeons want to give them. So you can see how the ICL might actually dominate refractive surgery because of general ophthalmologists who do cataract surgery having an ultrasound scanner that gives them the confidence to put ICLs in, something which hasn't occurred to date, I believe, because of the sizing issues. A lot of ultrasound papers have shown benefit to it, and in our paper, with Carlo Lovisolo, who passed away of a neuroblastoma 2 years ago, he was like the sizing guru on the ICL, and Starr hated him because he was at the users meeting every time, screaming about how high-frequency ultrasound was an essential part of their product, and they hated the idea of having a barrier to entry for their product. Not realizing, of course, that it would be a catalyst for the market expansion and acceptance of their product. It's kind of weird how the psychology of that works. But in our study, we used a different ICL than was recommended by the OCOS website in 50% of cases. look at our control of volt, it was way better when we used ultrasound than if we had used white to white. I mean, order of magnitude. So in my clinic, the last year, 35 consecutive patients are lens separation. The standard deviation of the mean of the lens separation is less than 200 microns. Ever since we've been using this. So, to me, this machine makes the ICL bulletproof. It makes it a bulletproof technology. You don't have to worry about intraocular complications, that's it, which are rare.
I'm not sure, but looks like you guys have a...
So for me, this is a great application. And of course, then there's the whole of cataract. But this is kind of unexplored. And the fact is that they've, like I said, over-engineered and managed to develop an algorithm that can scan the entire lens in multiple meridians to get the volume of the lens. And of course, this must relate to the ELP. It must do, because if you have an optic and a haptic of a certain length and a certain volume, you have a big bag, it's going to heal differently than if you have a small bag or a long lens or a short lens. I mean, these things have got to have an influence on ELP. And we do very well with cataract surgery. You know, 70% of eyes are within a half diopter without even trying. 90% if you try, which means we're left with 10% that are outliers. Can you imagine that if we were actually measuring the zonular plane and the lens volume before we did the surgery, I bet you we'd scoop up a few percent of eyes that don't go outlier. So I think this is the future of biometry, operating behind the iris, this dark side of the moon. We never see behind the iris, it's the dark side of the moon. And yet now we can see behind the iris. And by the way, it's a sterile disposal, so technically you could actually scan something immediately post with the lumen, hydrated so that it doesn't leak. But technically you could actually scan something and check where it is.
That was the word.
Back size.
If you're able to measure back size and volume.
Right. Maybe that is why some lenses rotate and some don't. Yeah.
They publish papers on that.
Okay.
Right.
Right. Okay, so these are the cataract things, the ELP, the elephant in the room. I mean, it's the hugest error that we have in cataract surgery, and no one is addressing it. Well, understood. No one could address it because there was no way of getting behind there and making measurements. So, overall, you can understand why I bought 2 of these, because, and by the way, I paid for these things. I didn't get a free one, even though I did get a check from Cornell University for $99 last month. Some patent that was in there from the early 90s that's went into this company. But I truly, I have a fiduciary interest in that I have some whatever through the patents and stock or whatever. But honestly, whether they sell 1 million of these or not, I make the same money. I don't have a financial interest in you buying this, but I do have an interest in you benefiting from what I've benefited the last 25 years. Because I can tell you that my practice, I moved to London, escaping the FDA in 2001, and I moved into a very, very competitive, hostile environment in private practice. And I started from scratch. And the fact that I had this technology by my side was my shield. It was like in Star Trek, shields up. Because no one could touch me. Because I could do things that others couldn't do. I could repair things that others couldn't repair. I could diagnose problems that others had assumed was one thing and I showed it was something else. So it was my protector against the competition, and it saved me from, multiple incidents of sudden death during the building of my practice in a competitive environment. But actually, what it really did was it gave my patients a level of care which wouldn't have been possible if I I didn't have all this information already. So I had some amazing mentors, surgical mentors, wearing Hugo Sutton, Simon Holland, Barraquer, Saldivar. I did fellowships with these people. But the person that taught the device that taught me the most about what I know about refractive surgery is high frequency ultrasound. There we go.
Yeah, did you mention that the biggest issue I had is people that had PRK years ago, small optical laser. There's so much remodeling. They come, they want an enhancement.
Right.
You don't know what the epithelium is. You take it off, now you got they're hyperopic. It's a surprise.
They're hyperopic for
they
3
have
months.
70 microns of epithelium.
No, I took LASIK in those patients.
Right.
I measure their epithelium and I program a flap 3 standard deviations below the epithelium. They love me. They're like, wow, the first time it hurt like hell for 3 days. This was amazing. It's like, technology's moving.
Sometimes if you don't know what they're
If you don't know, you don't know.